everybody. So in this lesson, we're going to talk about blood vessels, as you can see here on the board. And we want to look at them in terms of the highest flow to the lowest flow. So we're going to start with our biggest pipes, our highest flow, and these are arteries. Okay. And so arteries, obviously biggest pipes, are highest flow. They carry blood away from the heart. Away, arteries. Arteries away. So every single vessel that's carrying blood away from the heart is considered an artery. Okay? So that's pretty easy, pretty straightforward. And as they're carrying blood away, they're going to get smaller and smaller and smaller. So think of it as we have a bigger trunk, and it's going to branch into two smaller ones, which will then branch into even smaller ones. Kind of like a tree. And we find that a lot, is there's a lot of things that resemble other things in these systems. But the idea is as we get smaller and smaller, we're going to shift the name. So if we start with arteries, as they get smaller, we're going to call them arterioles. Arterioles. Okay, so really and honestly, an arteriole, oops, I forgot an E. Arterioles are just smaller arteries, but they're all carrying blood away from the heart. And when we're talking about the physical structure, if we were looking at it in a round, we have multiple layers. So right in the very, very middle is the actual tube or area that everything passes through. And so within these three layers, we have three separate layers. Okay, so we have our tunica externa, and then I'm going to kind of pull in another color. So this one is our tunica media. And we'll go for a green. And our inner layer is the tunica. And this one, can you guess what it's going to be? So we got externa, we've got media, and we've got interna. And so with these tunicas, what we find is that arteries typically have really thick flexible walls. Why would we need thick, flexible walls? Well, if you think about it, it kind of makes sense because if the heart is pumping, it's pushing this blood, causing pressure, and that pressure is going to stretch on these arterial walls. So we want to make sure that they are flexible to deal with that pressure. And the closer they are to the heart, the more flexible they need to be. So as we move into the arterioles, they're going to have thinner walls and they're going to be a little less stretchy, a little less flexible. Okay. So the next one in order of flow, so arteries have the best flow, would be our veins. Okay? And veins go towards the heart. They're carrying blood towards the heart. And I always kind of think about Spanish, and in Spanish when you say venga, veins, so come. So they're coming to the heart. So just like this did a branch from bigger to smaller, these are going to go from smaller to bigger. So these are going to join, and these are going to join, and so they're going to go in the opposite direction. They're going to go from smaller to bigger. So they're going to collect from the smallest into what we call venules, which are a little bit bigger. And then ultimately veins would be the largest, okay? So whereas we went from arteries to arterioles, and then we're going to get even smaller than that, we go from the little small to venules to veins. So we're kind of going in the opposite direction. And whereas these had really, really thick walls, these are going to have really thin walls. One. Sometimes they may not even have all three of the tunicas. But see, the walls are going to be a lot thinner than the artery walls were. Okay. These are high pressure. And these are going to be thin walls. And they are low pressure. Because they are low pressure, blood tends to kind of almost stagnate in these a little bit. So we actually find that a majority of our blood flowing through our body is really just hanging out in the veins. But because of this low pressure, we have things like, these actually have valves. And the idea of valves, just like in the heart, are to prevent backflow. So what we're doing here is we have veins that have valves, so as the blood moves a little bit forward, it can't go back since there's not a lot of pressure behind it. And so basically, how we move our blood, our veins, it moves through pushing from behind, it moves from skeletal muscle movement. We call that milking because it's basically gently massaging the vessels to push them forward. Okay. So we've got, and while this is just a small amount, respiratory pressure. So when you're breathing in and out, that actually helps move the blood in your veins. Okay, so this brings us to our lowest flow, least pressure. Basically, this is almost like it's a single file line, and these are the capillaries. And so what you'll often see is you end up with this like network. We call this a capillary bed because we've got all these little teeny tiny vessels. They're all basically about 1 cell thick. And so arteries come in. And remember, arteries, when they're teeny tiny, are arterioles, and venules come out. Okay. So our capillary beds are going to be about 1 cell thick, and they're actually just a little bit smaller than a red blood cell, so it really has to squiggle and squirm and try to move. Okay. So it has 2 key parts. We have what we call the shunts, and we have what we call the true capillaries. Okay. Changing out pens. So when we're talking about the shunts, they're kind of like a bypass. So the shunts are like a bypass. And what I mean by that is that we have sphincters, which are little valves will shut the capillaries and run through the shunt. So what we're saying is that kind of these outer bigger ones would be our shunts, and there are little sphincters, little valvey things that are going to shut off the flow through the rest of the capillaries. So then if we go back to our true capillaries, these are going to be the drop-off point for nutrients, gases, and will pick up wastes. So the reality is the decision, do we use the shunt or do we use the true capillaries, is totally tied to the needs of that tissue. So whatever tissue has this capillary bed, if it needs materials, will run slowly through the true capillaries. If it's good and it has all the materials it needs, it's going to use the sphincters, close off all those middle beds, and just run quickly through the shunts. It makes it move a little faster so that it will share less material, and we're going to ship it off to where we really need it. So hopefully this has helped you better understand arteries, veins, capillaries, and of course the variations of them, venules and arterioles.